Let us see the syndrome calculator circuit for 7,3 cyclic decoder. We have already seen cyclic or syndrome decoder for 7,4 code with two different GX. So the concept is same. So this is like a practice. This will become like a practice example for you. So here y is this one. Y is received code word and it has bit 7. Gx is x raised to 4 plus x square plus x plus 1. Now how many flip flops are there? Flip flops are 4. That is degree of gx is 4, so flip flops are 4. So these we have used 4 flip flops, 0, 1, 2, 3. After that this structure remains same for the decoder circuit. So as we have already seen in 7,4 cyclic code, the same diagram is there. Only how many flip flops? There are 3 flip flops, here are 4 flip flops. Then this line corresponds to highest degree or highest power, that is equal to x raised to 4. Then x cube is not there, so this line is not there. X square is there, so this line is there. Then x is there, so this line. Then 1 is there. After that, wherever line comes vertical, then you add one adder, which is a mod 2 adder. Then received code word comes here from this side. Then syndromes are how many syndrome bits are there? Syndrome bits are again 4. So flip flops are 4 as well as syndrome bits. Number of bits in the syndrome are 4. Like there in 7,4, flip flops are 3 as well as syndrome bits are 3. So the syndromes are taken as output of all flip flops. So you have to show these lines at the output of each flip flop. So next what we do, we obtain the equations. So equations are flip flop 0 input, this input, this one is equal to this plus this. What is this? Y. What is this line? This line is flip flop 3 output. Okay, then what is flip flop 1 input? So flip flop 1 input is equal to this line. This line is again flip flop 3 output plus flip flop 0 output. Then flip flop 2 input, this line is equal to flip flop 1 output plus flip flop 3 output. So this is flip flop 3 output, this is flip flop 3 output, this is also flip flop 3 output. Same is coming at each vertical line. So flip flop 2 input is flip flop 3 output plus flip flop 1 output. Flip flop 3 input is flip flop 2 output. Flip flop 2 output. Okay, so we form these equations. After that we are computing inputs for each flip flops, which is nothing but the present row, and the outputs are previous rows. So as we already know that you have to show y as when y is not present, then flip flop 0, all the flip flop contents are 0. So once again in nutshell I will tell you the operation of this circuit. So y enters into the circuit. At that time this switch is at this position, and once all the bits of y entered into the circuit, then this switch comes at these positions and the syndromes are taken out, S3, S2, S1 and S0. So let us form this table. So flip flop 0, all these are nothing but the values which are computed by the input equations of these flip flops. Flip flop or equations of these flip flops. So flip flop 0 input. So what is flip flop 0 input? So this is the initial condition, this one, this. Okay, then write down y. that is 1000101. This is your y, 1000101. Okay, so what is flip flop 0 input? That is equal to this 1 plus flip flop 3 output. Output means previous row. So 0 plus 1 is 1. Then what is flip flop 1 input? That is equal to flip flop 0 output plus flip flop 3 output, that is 0 plus 0. So this is 0. What is flip flop 2 input? That is equal to this flip flop 3 output means previous row plus flip flop 1 output. So this 0 plus 0 is 0. What is flip flop 3 input? That is equal to flip flop 2 output. That means this will come appear here. So let us compute for next rows. So 0 plus 0, this 0. Then 0 plus 1 is this 1. Because we have seen all these operation in this row. So every time we are not going to say that flip flop 0 input and what are the operations. Once again I will tell you that you have to see this one, y plus flip flop 3 output means previous row. So 0 plus 1 is flip flop 0 input. Then flip flop 3 output plus flip flop 0 output is equal to flip flop 1 input, this 0. Then this flip flop 3 output plus flip flop 1 output is flip flop 2 input, this 0. Then this 0 appears here. Same operations you have to do for each row. So then 0 plus 0, this 0. 0 plus 1, this 1. 0 plus 0, this 0. Then this 0 appears here. Then flip flop 3 is everywhere. I think in 3 operations flip flop 3 output is there. So this 0 plus y is this 0. 0 plus this 0 is this 0. Then the 0 plus 1 is this 1. And this 0 appears here. Then 0 plus 0, this 1. 0 plus 0, this 0. This 0 plus 0, this 0. And this 1 appears here. Then 1 plus 1, 0. 1 plus 0, 1. This 1 plus 0, this 1. Then this 0 appears here. Then 0 plus 0, this 0. 0 plus 0, this 0. 0 plus 1, this 1. This 1 appears here. Then 1 plus 1, this 0. 1 plus 0, this 1. 1 plus 0, this 1. And this 1 appears here. So this is the we have reached at the 7th bit of y, because it is of 7 bit. At that time these are the final syndromes outputs. So you have to take like this, that is flip flop 3, flip flop 2, flip flop 1 and 0, that is 110, 110. Why? Because when you take the syndrome outputs, you will first get S3, that is flip flop 3, then S2, S1, S0. So that's why syndrome you have to write like this, 110. So let us do cross verification of your answer that we already that we have also done in the previous 2 examples for 7,4. So cross verification of the answer. So y is this one. So yx is, this is 7 bit. So x6, 5 is not there, 4 is not there, 3 is not there, x square. X is not there, 1. So x6 plus x square plus 1. Sx is yx by gx. You have to divide yx, that is x raised to 6 plus x square plus 1. You have to divide it with gx, that is x raised to 4 plus x square plus x plus 1. So x6 by x raised to 4 is x square. x6 divided by x raised to 4 is x square. That is first quotient. So you have to write this x square. Then multiply x square with all these terms. So x6 plus x raised to 4 plus x cube plus x square. Then cancel out similar terms, x6, x square, remaining is x raised to 4 plus x cube plus 1. Now x4 by x4 is 1, so quotient is 1. So multiply 1 with all these terms. So x4 x square plus x plus 1. So x4 gets cancelled out, 1 gets cancelled out. Remaining is x cube plus x square plus x. You have to stop here. Why? Because 3 is less than 4. where you have to stop in division method, when when this portion is has less power than the gx highest power. So this polynomial has highest power 3 and gx has highest power 4. So stop here. That is your remainder. So remainder is sx. Sx is, so Sx, I should have written it Sx as remainder of yx by gx. Okay, so Sx is remainder of yx by gx. So that is equal to x cube plus x square plus x. So syndrome has 4 bits, as we have already seen that 4 flip-flops, 4 bits, or 7 minus 3 equal to 4. So 4 bits means highest power is 3. So 3 x3 is there, so 1. X square is there, 1. X is there, 1. Then x raised to 0 is not there, that's why 0. X raised to 0 is 1. So 1 term is not there, so 0. So syndrome is 1110. So this is your syndrome, and in this method also, in the circuit implementation, we have got the S as 1110. So our answer is correct. So this is it for this syndrome calculator 7,3. In next video we will again see the same syndrome decoder circuit, but with gx x4 plus x cube plus x square plus 1. So that and if you see all these syndrome decoder circuit, I think we have covered 3 till now. So if you see that, you can solve any problem. If they have given you gx and they have given you y, then you can draw this circuit and also prepare this table. Cross verification is not necessary. If you have time, then only you can do the cross verification. Otherwise, that is not needed.